Now we have to answer another question here. What is that? Could we be able to solve this same question using the general equation of a simple harmonic motion given by x equal to a sine omega t plus phi or x equal to a cos omega t plus phi? If that is the case, if that's a given case here, how do we approach this? If x equal to a sine omega t plus phi, derivative of x with respect to time. Now see, whenever I write x, it directly implies x as a function of t, v as a function of t, right? Likewise here, x as a function of t, velocity as a function of t, acceleration as a function of t. Okay? So velocity is derivative of x with respect to time, which is a omega cos omega t plus phi. Acceleration is therefore minus a omega square sine square omega t plus phi. And a times sine omega t plus phi is equal to x, and therefore a is equal to minus omega square x. Similarly, x is equal to a cos omega t plus phi, and acceleration is a cos omega t plus phi times minus omega square. So this becomes a is equal to minus omega square x. Very similar to what we did in the previous solution. What I'm trying to convey here is this plus phi doesn't matter when it comes to the solution. Where, of course, it does matter, I'm not pointing out that phi is not at all relevant. No, it is relevant, but with specific regard to this question, it is not. Okay, how? Let's focus ourselves into this part here. So if x is equal to a sine omega t plus phi, we know that v is equal to a omega cos omega t plus phi, and acceleration is minus a omega square sine omega t plus phi. How? From this. Okay. Now, once you have this, can I square v over here? So v square is a square omega square cos square omega t plus phi, and a square is minus square, which is a square omega raised to 4 times sine square omega t plus phi. Okay. Yes, this is where a minor difference comes in the previous approach. Now, can I bring this a square omega square to the LHS? Which gives me v squared by a square omega square is equal to cos square omega t plus phi. Similarly, can I bring this a square omega to the power 4 to the LHS, which gives me sine square omega t plus phi in the RHS? Now, what do we have? Exactly, we got two equations, and RHS being cos square omega t plus phi and sine square omega t plus phi, which means when they are squared and added, oh, in this case, they are already squared. When they are added, the RHS becomes equal to 1. Therefore, v squared by a square omega square plus a squared by a square omega to the power 4 is equal to 1. Now plug in the values, which are velocity is 2 meters per second, acceleration is 16, displacement is 4. So acceleration is 16, amplitude is unknown, velocity is 2. Do we have displacement here? Okay, we don't have displacement. But we know the relationship between acceleration and displacement, which is a is equal to minus omega square x, which means acceleration 16 is equal to, of course, by taking the magnitude, we have 16 is equal to omega square times 4. Therefore, omega square is equal to 4 and omega is equal to 2. And again, we come to the question, why omega is equal to plus or minus 2? While omega is equal to plus or minus 2, we take only omega is equal to 2, which gives us the question why, right? please make sure that you, it's a very kind request, make sure that you, while you're taking notes along with me, you think of this. Why are we neglecting omega is equal to -2? Think of on this on your own, and then try to come to a conclusion. Write back to me if you get the correct logic. Okay? Yeah. So from that point, we have omega is equal to 2 here, right? So omega is 2. Omega is equal to, this omega over here is equal to 2. Omega square is equal to 2 square, right? Coming back to the arithmetic part. 2 square is, okay, so I've taken a square common here, which is square, the amplitude square in both the denominators. So 1 by a square times 2 square by 2 square plus 16 square by 2 to the power 4 is equal to 1. And 1 by a square times 2 square by 2 square is 1. 16 square by 2 to the power 4 is 16. So 16 square by 16 is 16. 16 plus 1 is 17. And a square is equal to 17. Therefore, a is equal to root of 17, which gives us the correct option as the amplitude of motion is root x, where x is equal to 17. Hope that makes sense. All right. So yes, that's what something I wanted to tell you, primarily about solving these questions, about choosing the reference equation. And I've taken two set of equations, x equal to a sine omega t, x equal to a cos omega t, and of course x equal to a sine omega t plus phi, and x equal to a cos omega t plus phi, and I've arrived at the same numerical solution. Okay. Now let's go to the third question.